Um, Good evening to all my friends and new friends in Azerbaijan. It's morning for me, so thank you to the Groundbreakers crew for working with my time zones. I'm a better presenter at 11 a.m. than I am at 6 a.m. This is my contact info. Feel free to reach out to me via email. If you're on Twitter, I tweet too much, but I am pretty responsive on Twitter. And the topic today is RESTful web services for someone that works with Oracle database. So this presentation kind of evolved from a training that I provided to our internal Oracle support staff. So they are used to supporting products like SQL Developer and Oracle Forms and even in things like Enterprise Manager and the old Oracle Designer and SQL Developer Data Modeler. So they're very comfortable with database concepts and client tools. But when it comes to working with the web, there were certain concepts that were just brand new to them. And so I did an hour session with them, and they found that to be very helpful. And I'm very lazy, and I don't like to create presentations to be used just once. So I thought, this might be of interest to an Oracle database developer who needs to start supporting or building or helping the web development team with REST services. So that's where this slide deck evolved from. And so if you're doing web development on a full-time basis, some of these slides will be very basic and you can tune out a little bit. But I also have a good mix of how those basic ways of the web fundamentals come together in such a way that our product, Oracle REST Data Services, or ORDS, is able to deliver these things in a very simple and easy way for the data in your Oracle database. So that's what we're going to do for the next 45 minutes. I think I have more content than I can fit in 45 minutes, so I'm going to stick to just the slides. If anyone has a question, I'll try to keep an eye on the Q&A, but I'll also stay on for a few bonus minutes at the end to tackle questions. So let's get into it. So these are the topics that I want to cover today. I want to cover, just what is REST? How does HTTP work? How does JSON leveraged? And then some fundamental things about REST data services, which at Oracle, we get bonuses for every new acronym we can come up with because we know customers love learning new acronyms. And so 10 years ago, we came up with ORDS. And this one does come in handy because if I were to say Oracle REST Data Services every single time, this would be a 2-hour presentation instead of an hour. So ORDS 101, I'm not going to cover too much on the install and config, more on the development side, but I'm happy to take install and config questions. And so in this diagram, I have our ORDS logo kind of sitting in the middle, talking to one or more Oracle databases using JDBC connection pools, and it's handling the client requests coming in via HTTP, and it's speaking JSON back and forth. So that's kind of at a high level what we're doing. And something we're trying to remind customers of is when you're working with an Oracle database, the things at the bottom, they don't always have to be just relational tables. By the way, I love relational tables, and I would always use a relational table up until the point where the requirements of the project dictate that I go use something else. And that something else in the Oracle world could be a JSON document store where you're using collections and documents. It could be spatial data. It could be things on the blockchain. Instead of JSON, we might be working with CSV or XML or some other type of data exchange format. It could be text. We could have graph. And the Oracle database is able to give you a singular interface to this type of data, and ORDS is able to leverage that. And so you can build these RESTful web services, of course, for your relational tables, but also for all of these other things as well. So if you want to learn more about how ORDS works in this, what we call the converged data model, I have a YouTube video that goes into more detail on that. And if you want to learn more about just ORDS in general, if you go to my blog, thatjeffsmith.com, at the very top, I have some links. And these are kind of like curated pages where I have a breakdown of some different topics and kind of help you get into the tech instead of just going through and Googling stuff randomly. So for my resource page for ORDS, I've got some good additional 101 blog posts and a video you can watch. So if this is too much for you to consume all at once, don't worry. I've learned this stuff myself over time. But once you get into this, I do promise it becomes quite fun. Or it's fun for me, or maybe I'm just a weirdo. One of the questions I get from a database person is, why should I care about all this REST stuff? And really what it comes down to is the rest of the world is already using REST APIs to do pretty much everything. Deliver and power data for applications, for automation, for creating or destroying test environments. And if you look at APIs in general, about 70% of them that have been deployed are REST-based. So, some of the most important data, or almost all of the most important data in your organization, is being stored and managed and protected and optimized in an Oracle database. So if that needs to interact with the other things in your tech stack, then you're going to have to start worrying about REST APIs sooner, if not later. And as DBAs, if you're not helping your developers with this, they're going to go pull that data out in some other way and go stick it in some other data engine where they can do REST services the way they want to do. So if you've been saying no a lot as a DBA, and you want to protect the data and keep it secure and perform it in an Oracle database, you need to start empowering your developers, and ORDS can make that very easy for you. It can make you look like the hero when you say, hey, let's go, versus saying, no. In an Oracle environment, we have the Oracle client, and you have the drivers and the SQLnet and the TNS names all set up, and then you get to learn about Oracle usernames and passwords, and that's all fun. But in the HTTP world, it's very ubiquitous and it's very easy to use. Pretty much any programming language or any sort of development environment or computer environment has access very easily to make calls to HTTP. And you can speak to an Oracle database via HTTP without worrying about all that other stuff I just mentioned. And all you need to know is what's the URL and what type of request are we going to make. And then you can immediately start getting data out of your database, or putting data into your database, or interacting with your existing PL SQL APIs, all via HTTP. So what ORDS delivers is this sort of HTTP gateway for your Oracle database. It's set up to allow someone to build APIs that follow that REST paradigm if they want to. And it speaks and translates JSON. So when you make a request that has a JSON payload on the request, ORDS can see that and translate that and turn it into inputs to your PL SQL APIs, for example. We call the Oracle stored procedures just like you would in SQL+, and when we get the results, instead of sending back that ref cursor or the result set as something that a JDBC driver would understand, or as even just standard output that you would have to screen scrape or do something with, we instead take those results or take that output and paginate it if necessary, and we output it back as a JSON document for you. So you don't have to write any code to do that stuff. There are 5 primary features or use cases for deploying ORDS, and what I'm talking about for 95% of today is the second one, the RESTful services or the web services for an Oracle database. So using HTTP to get, put, post, and delete things in a database, that's all made easy with ORDS. Now, the other things, the web listener for PL/SQL, the PL/SQL gateway, that was the original use case for ORDS, and it was known back in the day as the Apex listener. And so when you need something to, make the requests to the PL/SQL APIs that powers Apex and get the HTML output back and present it on your mobile device or on your laptop, ORDS can do that. And 7 or 8 years ago, we decided, hey, this REST stuff is starting to take off, so let's expand what the product can do. And so that explains why we rebranded the product from the Apex Web or the Apex Listener to Oracle REST Data Services. And I just want you to understand, you do not have to use Apex to take advantage of ORDS. If you want to take advantage of things like Apex, absolutely do so. And it's a game changer in terms of a low-code solution for quickly deploying enterprise-class applications. If you've already have deployed ORDS for making your Apex apps available, then you've already got everything in place that you need to start making the RESTful web services available as well. And I know Apex is very, very popular in Europe, and so the chances are you've already got ORDS there for that. So what I'm saying is you can now quickly, with a few clicks or configuration parameter changes, now quickly publish RESTful web services in addition to those Apex apps. We have SQL Developer Web. Hopefully this isn't the first time you're hearing about that, but if it is, it's a single page web application delivered by ORDS itself, and it's powered by REST APIs. And instead of having SQL Developer on your desktop, where you have that JDBC driver and your TNS names file, and you're connecting to databases, and you're doing things like running queries and executing stored procedures and managing users and getting real-time SQL monitoring reports, you can do all of that now natively in your browser. And we can work with as many databases as you want, and you can run your queries, and there's nothing to install. So that's been available for our on-premises Oracle database customers since last year, and it's been in the Oracle Cloud for 3+ years. So you get SQL Developer Web out of the box, for example, when you create or access your Oracle Autonomous Database Cloud Service. But if you install ORDS in your data center, on your laptop, or in your Docker container and set it up, you can have SQL Developer Web there as well. I've already spent too much time on this slide. You can read the other 2 bullet points for yourself. So, like I said, back in the day, we had those stateful applications with persistent connections, and you had all the clients and driver setup required. What this diagram does not show is the architecture where you had a middle tier with a pool of connections so that your very busy apps could share connections. But at that time, it's still at that point, you've got the stateful and the persistent stuff going. That doesn't map well in a mobile world or a web-powered world. And the core bits of REST are that your requests are stateless. So you don't know what happened in the call immediately preceding the one that you're making now. So in the ORDS and REST paradigm for an Oracle database, every time you make a request, you're getting basically a new connection. And we're doing everything via HTTP. I'd like to share pop culture tips and tricks as well. So I love this movie, The Train from Busan. It's a Korean horror flick. It's their take on a zombie apocalypse. Maybe it's too close to home at the moment. I don't know. But there's this scene in the movie where the movie's protagonist is in a train on his phone trying to get his friend to pick up and say hi. And, this is a bullet train, it's going very fast. So, it's hopping cell towers. Imagine in the old world trying to run your Oracle application on a phone over SQLnet and a stateful connection. That just wouldn't be a very good experience for the end user. So things like ORDS and REST paradigms and HTTP, much more friendly experience. As your connection goes in and out, that's going to be okay, because every time you make a request, everything that the backend needs to know is included on that request itself. So I've already started throwing out a few terms. I'm sure everyone has heard and has a somewhat basic understanding of what HTTP is. And oftentimes as an IT professional, we get in trouble because we say HTTP and what we're really saying is HTTPS. And we do that because that last letter makes it harder to say. Now, when we're dealing with data in our database, that secured part is very important. And so when you hear me say HTTP, 95% of the time, what I'm really saying is HTTPS. I'm going to go over this architectural style known as REST, and I'm going to go over a little bit of JSON, but I think most of us are already comfortable with JSON at least. So the hypertext transfer protocol, very old, as old as the internet itself, basically. It's what makes the internet available. You have a request, and it uses a set of verbs, and you have responses come back from those requests that have a status code attached, which can tell the client things like, oh, your request worked just fine, or hey, your request worked just fine, and oh, by the way, you created this new thing, and here's how to go find this new thing, or hey, you got the wrong number, you're trying to talk to something that's not there, or uh-oh, we made a boo-boo, something very bad happened, you need to talk to tech support. And of course, it supports authentication, which is very important because you don't want people accessing your APIs that shouldn't be there, that don't have the proper privileges or the right keys. Now, I'm somewhat surprised by how often I end up showing this to someone and they've never seen it before. But if you're in a web application, any web application, you can use something like Chrome's developer tools, although Edge and Firefox also have their own version of this. But as you're clicking around in the screen, what DevTools does is it shows you all of the different HTTP calls that are being made. And it shows the type of request that's being made, where the request is being made to, and it can also show you the payloads or what's included in the body of the request. Now, what a lot of people will use this for is to look at the top part, the timeline, because they want to know why their page is taking so long to load. And it turns out it's because of that 15 megabyte animated GIF that Jeff put on his webpage because he's dumb. But you can also use this to kind of teach yourself HTTP a bit. So in this case, we can see SQL Developer Web is running a SQL statement. And the way it does that is it does a post to this underscore SQL endpoint being powered by ORDS. And we can see also that the status code on the response that came back was 200. And we can ask DevTools to preview the response contents. And so in this case, we can see a formatted JSON document. And SQL Developer Web can take this JSON document and use that to paint the screen. And now we happen to use Oracle Jet, which is Oracle's official JavaScript library and set of components for building rich and powerful web applications. But the general gist is any developer can take these JSON responses and use it to paint the beautiful screens or just to power the command line interfaces or automation frameworks. So requests and responses. Anytime you do anything in HTTP, you're going to include an address and a method. Those two things themselves are always required. And oftentimes you're going to include some other things that the server needs to know about via headers. And you can optionally include a body. You generally don't use bodies on a GET request, but you'd almost always have a body on a POST or a PUT. And for our sake, most of the bodies are going to be JSON documents, although they can literally be anything. Now, one of the headers that you'll use is to tell the server what type of content is coming over, and that's done via the content type header. Now the server will use that header as well to tell the client, hey, what's coming back down. So if it's sending back a PDF file, that's how your browser knows to launch Adobe, or if you're sending back an MP4, that's how your mobile app knows to open up whatever your default video player is. The response that comes back from the request is going to be what you asked for. So in the REST paradigm, you have collections and items, and you're performing these verbs against these things. So I've asked to get this thing, this item in the collection, and the server response is going to be, oh, hey, that thing you asked for? Sure, here you go. Here it is. And oh, by the way, it's a JSON document. And that item is represented by the body of the response. Here's what an HTTP request looks like in curl. Curl is the ubiquitous way of describing your HTTP requests. It's pretty much available to any command line interface. And I will say it is universally available, but almost also universally loathed and hated because, well, I hate it and I loathe it. It's not very user-friendly. I will almost always play with a REST client instead. And when I am forced to go into curl, I usually spend way too much time on Stack Overflow Googling the exact right syntax for getting this stuff the way I want it to work. Although those REST clients can help you formatting these, I've found them to be sometimes problematic. So anyway, in this request, we're doing a post to this ORDS-powered REST endpoint. In this case, it's the Database Management API. And I'm asking ORDS to go kick off a database data pump export job. And I'm saying, go export my beer and my hockey tables and write the output to the data pumpter and kick off two processes to go do this work. So there's my method, there's my header, there's my body, and what I didn't call out was the URL, or the URI as they say, the Universal Resource Indicator, which is this. I think you can basically switch out URI and URL, and the dev nerds might make fun of you, but who cares what they think. This is what a response can look like again. So we've got the status code. So this is very important. And it's very important when you're building your REST services that you conform to these norms, to these things that define HTTP and that define the REST architectural style. Because when you start not doing that, you start confusing your API consumers. So as a DBA, if you start building a bunch of REST APIs, and your responses aren't in the format that's expected, or if you are falsely advertising what's happening, like if you show a 200 versus a 201 when you create something, that makes your API not likely to be used. Or if it is used, it's going to be used incorrectly, or it's going to cause problems. And ORDS gives you everything you need to create APIs that follow and do the things that they should do, like including links back to things that you've created so that your app knows what the next step is. And you can also include links for where that person came from, and links for where to go if they want to learn more about the object that we're dealing with. So this is the header that's just saying, hey, here's what's going on. And then here's the meat of the request, which is the body. In this case, again, it's a JSON document. So this is probably the thing that was created. So this is the job that was created and the details for the job. And we also got a bunch of links here that the app developer can take advantage of for building the screen or the UI for this. So I can go click here to see the job, or I can click here to get a description of the interface we're using, and I can also click here to go get the log of the job, and I can go here to click to get the dump file that was created for the job. So when we start building REST services in ORDS, we have to know a few things. One is we have to know the pattern and the URI template, basically. So what's going to be on that HTTP address? Is it going to be something slash item? Hopefully it's not going to be that. That's kind of generic. And how do we, what are we representing by that URL template? Is it a row in a table? Is it a response from a PL SQL API that we're marrying ORDS to? Is it a pluggable database in a container database? So one of the first things I do when I start thinking about a REST API that I need to build is I'll build a sort of model on paper of what the URLs and patterns are going to be. And I'll try to imagine, how is the person using my API going to want to walk it? Where are they going to start? Where are they going to need to get, when they start creating things, if they create something, there's a really good chance they want to get that thing they just created too. So, how's that going to be represented in these URLs? The handlers are the verbs. So for my REST service, if I want someone to be able to get something, and you're going to have a SQL statement or a PL SQL script or anonymous block used in the backend to deliver the thing that the person's asking for. And so when I say ORDS is fun to use, where it's fun for me is when I can start using the SQL and the PL SQL that I already know to build REST APIs to do things like upload images from my mobile phone that get stored in a table, and I get a link back that I can click on to get my picture back. Like, for me, that's fun. That's a lot more fun than the stuff I was doing for 15 or 20 years, which was writing select star from queries so people could build Excel spreadsheets. When we're building interfaces to things like queries and stored procedures, of course, we have to be able to support things like parameters or input variables. So in ORDS, when you're building these REST services, we give you everything you need to be able to accept things off the header or off the body of a request that then get tied to the 4 things that get used on your PL SQL call, or to the 4 bind variables needed to run your SQL statement. And then the last thing we do is, in addition to giving us the SQL or the PL SQL, is you tell us what's the format of the response going to be. Is it going to be a page set of rows powered by a SQL statement? Or maybe it's going to be a binary object with a MIME type of MP4, because maybe you're sending back literally the contents of a blob or a binary large object in a table. If we try to break down every part of an ORDS call, we have that handler, that verb. In this case, it's a get, and we're going to have a base part of the URI. And that's going to basically start with the location of the mid-tier web server. And so you could have WebLogic or Tomcat with ORDS plugged into that as a Java servlet, or we could also have ORDS running itself as a Java application, in which case it spins up a Jetty web server. So when I'm running ORDS on my laptop, I don't spin up Tomcat or WebLogic for that. I just have it run as a standalone Jetty web server process. And so when I talk to ORDS on my machine, from my machine, it's like localhost port 8080 slash. And so if I talk to just localhost 8080 slash, I'm going to be getting the static files out of the Jetty web server itself. But if I do slash ORDS, that tells Jetty, hey, Jeff's talking to the Java code base here, and he's going to start doing the database stuff. So the thing that comes after ORDS slash is going to be either this module or this object in the database, or I might have 15 databases that I'm supporting. So the next thing that comes after ORDS is going to be this pattern that tells me which database we're going to work with. So it might be ORDS slash dbdev, or ORDS slash db5, or ORDS slash prod, or ORDS slash my application name, which is in a specific database. And then after that's going to be the thing in the database, which we've modeled with these URI templates. So we give you modules, and the easiest way to think of a module maybe is like a PL SQL package. It's a collection of related things. And you could create one module for every thing in your system if you want, or you could have one module with 25 templates under it. I try to break them up logically, just like I would a PL SQL package. Inside of those templates, we're going to have those verbs mapped up to the things that are happening in the database. So when we get that far, that's when we're ready to start writing our selects, our truncates, our begin, dbmess, blah, blah, blah calls. Now, our team builds REST data services, but we're also the team that builds SQL Developer. So in SQL Developer, if you want to use SQL Developer, we give you a complete IDE for building your RESTful web services. If you're an Application Express or Apex developer, they give you a REST IDE built into Apex. We also have a PL SQL API for defining these. So you could do all of this from SQL CL if you wanted. In this case, I've got a module created, and I have a URL template let me just break this down. So my module in this case is called Aura Magazine. And under Aura Magazine, I have a template called media slash. Generally what that means is if I do a get on media slash, I'm basically asking kind of like for a directory listing of stuff. So I'm expecting to get more than one thing back here, unless there's only one thing in this collection called media. And I have two verbs under this. I have get and post. Post has these 4 parameters attached to it. So that's template 1. Template 2 is I have media ID. So this is something, an item inside the collection. In this case, it'd almost always be just the one thing. It could be more than one thing. This could be like an adjective. I could do media slash JPEG, and I would get back all the JPEGs back, for example. And these URL templates, they can be quite complicated. I could have multiple, so this is a bind variable basically built into, so which means it's variable. So I could have media slash colon X slash colon Y slash colon Z slash content slash colon W if I wanted. So in SQL Dev, I can create all of these modules, I can create the templates, and then I can attach the handlers underneath them. In this case, for my post, I need to be able to deal with those request and those response headers. And the way we deal with the request and response headers in the database is the same way you deal with everything else, which is bind variables. So when you're working with the SQL or the PL SQL, you can easily refer to those existing values. So if you have a request header, it's already set to something, and I can read it directly in using this bind parameter called file_name. So if I want to have a local variable inside my PL SQL block, a varchar2 or a clob or something, and I want to initialize it to that bind parameter, I'm sorry, initialize it to that header value, I can just refer to that request header as colon file name. And when I'm ready to start shoving stuff back out in the response, and I need to put something onto the response body or the response header, I also have bind parameters for that. So the name is the name of the response or the request header itself. This is how it will show up in the HTTP response. And the bind parameter is how I refer to that thing in my Oracle code. So I've done a lot of talking to just now get to the point of showing you some of the database code that makes a REST service possible. And this is very simple. And I made it simple on purpose because to build these things is generally quite easy. Now to build them in a performant, secure way might be a little harder, but I'm betting that most of you already have PL SQL APIs that some of them date back 20 plus years that you can just immediately leverage via ORDS. So in a lot of cases, your REST service calls are just going to be PL SQL wrappers onto those existing PL SQL APIs. Now they could be basic inserts, kind of like what I got here. So here I'm mixing PL SQL and SQL. So in this case, what am I doing? I'm taking the file that I'm trying to upload and I'm putting it into a table. And as I'm doing that insert into the table, I'm getting the contents of the request body. This automatically goes into a blob, which is nice because it makes inserting that into the blob into the table very easy. And I'm taking advantage of the SQL feature where we get the ID that was created from doing this insert. That could be from an identity column or it could be a classic trigger sequence. And I'm taking this image ID, in this case integer, so like 5 or something, and I'm using that to construct the link that's going to be included in this response. So my response is going to be, hey, we created this thing. That's what the 201 says. And to be nice, and I recommend you try to be nice, when you create something for someone, what's the next thing they're going to ask? Well, where is it? Either take me to it or just show me how to get there. And that's what this location variable does. So it's saying, hey, it's right where we are right now, /5, or whatever this number is. So I do my post to the API, and I include a few things. I'm including the file that I'm inserting, and I'm being nice to the API. I'm saying, hey, this is the name of the thing that I want to insert, and this is the type of thing that I'm inserting. And the response is, hey, that thing you gave us, we took it and we made something with it, and here's how you can find it. Here's how you can go get it. So this 201 is not an accident. Oh, stupid Zoom. So I've set that myself. And this location link that's included back, that's also not an accident. I am doing that work to make that possible. If I were a bad API implementer, I might use status 200 instead of 201. My response maybe should be a 300 type where I'm redirecting the browser to the thing we just created. So why even make them take the bother of clicking? You know, maybe if I upload something, I immediately want to see it. So you can do that too. It's up to you. I said earlier, it's almost always HTTPS. That is encrypted end-to-end traffic. If you're in an airport using their free Wi-Fi and you don't see the little lock in the browser, then make sure you have your corporate VPN going, because when you're doing your email or your Twitter or whatever, your banking, God forbid, don't do your banking in an airport Wi-Fi. If it's just HTTP, anyone that's on that network can see your stuff, or you should just assume anyone on that network can see your stuff. You're much more protected with HTTPS. Now, one of the caveats is if you've got pure backend traffic on secured networks and you've got machines talking to other machines, they will often just come down to HTTP because it's easier because they don't have to negotiate certificates. When you stand up ORDS, and you stand up ORDS and you tell it to run HTTPS because you're dealing with your Oracle database because that's the right thing to do. If you're using the embedded Jetty listener, you won't be calling port 8080 anymore. You'll be using the default HTTPS port, which is 443. And if you're using, again, that Jetty web server, we set up a self-signed certificate for you. Now, you don't generally want to use those. They're not the best, and that's why you'll see in things like Chrome, the warning screen saying, hey, this server isn't set up the best way. You have to do this special click here to show me the content anyway. But what you can do instead is just go get yourself a certificate from something like Let's Encrypt. And if you do a Google search for ORDS and Let's Encrypt, Chris Rice has a really nice blog post that shows you how to go get that going. As a DBA or developer on the Oracle side, you should be very much concerned with security, and you want to think about security early on, not at the very end. And yes, REST APIs are awesome, and they make building web apps and other things very easy, but you also want to make sure things are always protected, meaning that it's going to require you to tell us who you are and to also show us that you have what you need to access the thing that you're asking for. There are things and times where you might want to set up unprotected things on the internet. Oftentimes developers forget to lock these things down, and that's where you have these huge security breaches where someone finds an entire database available that doesn't require the requests to be authenticated and authorized. But you might have an open data platform where you just want someone to be able to anonymously come in and get stuff, and that's fine. Otherwise, you're going to want to have these things in the database protected, and we protect those with privileges and roles, which are similar to database privileges and roles, but not exactly the same thing. So there's a lot of different types of authentication, and ORDS supports a lot of different types. Basic auth, there are very few production things that still work on basic auth. And generally that's because when you make these requests, you provide the username and password on every single request. And if you accidentally do that once on HTTP versus HTTPS, then you've just shared with the world your username and password. More common, we've got cookie-based authentication, and that's where you include your credentials once and you get back a cookie that is there that ORDS can see, and it's like, okay, they're good to go for like the next 60 minutes, and then once that expires, you have to walk the username password thing again. That's why you see in SQL Dev Web, like after half an hour, it'll say, hey, your session's expired. We're doing that via cookies. We also have OAuth 2. Now actually OAuth 2 is not that complicated, but for this session and for like the 101 concept, I'm going to say it's too complicated. I don't have the time, especially since I've got 1 minute left. Authentication is handled by the web server. So that could be WebLogic, it could be the Tomcat where you have ORDS dropped in and running, or it could also, in this case, be ORDS itself if you're running it as the standalone Jetty web server. So it's up to WebLogic and Tomcat, or in some cases ORDS, to confirm that you are who you say you are. And one of the beauties of WebLogic is there's a lot of WebLogic schemes out there where it's somewhat simple to plug into things like single sign-on systems that your corporate IT already have. So all of your employees already have users in WebLogic, and it's just a matter of you giving them the roles or the privileges required to access the things in the database. So at that point, it gets pretty easy. ORDS just is told, hey, Jeff is here, and Jeff has ABC role. He wants to go talk to this API that you're in charge of, and ORDS is in charge of saying, oh, well, that API requires the DEF role, and Jeff only has ABC, so I'm I'm going to deny that request with the unauthorized HTTP status code. If you don't have that really cool single sign-on thing going with WebLogic, then you can use things like database authentication or basic authentication. The best thing to probably start with if you're rolling your own from scratch is to use the ORDS provided OAuth 2 workflow. And there's lots of examples out there on how to do that, both for on-prem or even in the Oracle Cloud with Oracle Autonomous. I'm going to skip this. Okay, so here in ORDS is where you go to either protect a set of patterns on the API or very specific modules with the roles and privs. And this is what you get if you try to talk to something that you're not supposed to get. Just really quickly on some REST API basics, I see developers making some common mistakes, and generally where they start making the mistakes is what you want to do is have a thing, and then you want to do something on this thing, like a get, a post, a put, or delete. And where people make mistakes is they make the thing called like create imp. So if I do a get on create imp, what does that do? That's where you start confusing your API consumers, because they're expecting something called imp that they would do a put or a post on to change or create that employee, not do a get request on something called create imp. So you want to avoid the verbs in your REST APIs. So yeah, this is one of the first things that when someone asks me to review their APIs, I'm looking for verbs in the URL patterns because they're easy to spot. Now, ORDS will let you do this. It'll let you do it in the bad way. We're not, totalitarian. We're like, oh, I see you've got a verb there. We're not going to let you go. But it's going to be up to you to decide how much you want to follow the REST paradigm. And it's up to you to provide the links and the right status codes. So again, I try to start modeling my templates first, get those right. And then once I have the templates, then I'll start throwing the verbs on them, and then I'll start throwing the SQL and the PL SQL on them. A very simple request, I want to get a beer. So I need to know where the beer is. And the server is going to respond, sure, here's your beer. I might make another request. Hey, I want to put a beer in the fridge. And their server responds with, hey, yeah, here we did that. And here's the address of your beer if you ever want to go get it again. JSON. So JSON won the format war. I'm not saying it's better than XML, but people like it better than XML. It was made for JavaScript, but it's being used for everybody now. And people like it because it's flexible. And ORDS supports it, and we can basically map anything in your database to JSON for you without you having to write any code. ORDS is there to get your requests, make them for you, get the outputs and responses, and format it into the JSON for you, so you can concentrate on the REST APIs themselves and the SQL and PL SQL powering those, and we handle the cool HTTP stuff and the JSON stuff for you. I've really gone beyond. So I just wanted to, well, really quick. So an HTTP request powered by ORDS, you're going to have an HTTP request just like always. It's going to get routed to a machine where ORDS is running. ORDS is going to take that request, figure out which database to go talk to, grab a connection on the JDBC connection pool, go do that work, get the output from that work, and send it back to you in JSON. And then throw in here the authentication authorization workflow too. Here's what a ORDS response looks like. In this case, I'm said, hey, go get me all of the employees in Department 50. And I've also asked it to be paginated. This is a large department. So instead of sending back 10,000 employees back to my mobile phone, I get the first 25 with links to the next page. And ORDS is doing this paging for you. You don't have to worry about how you would code it in such a way to break the items up into groups. So I'm at the very end now. Just to let you know, this is included with your Oracle database, whether it's a free database, a commercial database, a cloud database, an on-prem database. It's available at no extra cost. And sneak peek, the next version of ORDS will include a full REST IDE built into SQL Developer Web itself, so you can stay in your browser 100% of the time and even walk those OAuth 2 workflows. And if you want to learn more about ORDS, you just got to Google. I've got tons of stuff out there. So I went 6 minutes over. I feel kind of bad. Oh, by the way, Tim Hall at Oracle Base, for some reason, likes ORDS too, and God bless him. He's written a ton of articles and done a ton of YouTube videos himself on ORDS. And so I highly recommend his stuff, especially because I like his British accent. And I'm quite chuffed that he spends so much time talking about ORDS. All right. Thank you so much for giving me this time today. I'm happy to say goodbye. I'm also happy to take some questions.
Yes, no questions so far. Just Babu, thank you for the nice 101 presentation. So people don't be shy. Jeff is here to answer your questions. Okay, we got one question.
Can I say something about GraphQL in ORDS? So GraphQL is an alternative to REST. Some people don't like REST because it's a fixed API, and when you ask for something, you get that thing back. And GraphQL is starting to get more and more popular because it's built into it. It has the ability to say, I only want these small pieces of this thing. Now, we're evaluating adding GraphQL support to ORDS, so you can use ORDS to deploy GraphQL for your Oracle database. But ORDS itself has a lot of native features built in to give you the same thing that GraphQL gives you, but only using a REST paradigm. So as customers start asking for GraphQL, I can start prioritizing when we're going to make that happen. But for right now, I'm seeing it as more of a curiosity than an absolutely must-have kind of thing. If you're in that must-have space, then you need to contact me and let me know. Can we call a PL SQL proc or function via ORDS? Absolutely, you can. So we have an auto feature where you can take a PL SQL object and publish it as a REST API and just call it directly off the /this/that, and we run the code for you. But some of the screenshots I had were anonymous blocks that were calling PL SQL programs. So with ORDS, you can do anything that you can do in an Oracle database with SQL or PL SQL, and that includes calling other PL SQL things. If that PL SQL returns 5 ref cursors, then you could have ORDS return back 5 JSON documents, including the contents of those 5 ref cursors.
Thank you, Jeff, for answering the questions. Oh, maybe somebody else did something.
I think they're probably ready for a coffee or a beer or a nap. It's the end of their day, right?
Yes,
I've put them
a
to sleep.
a beer sounds nice. Oh, yeah.
Yeah, if your database has a database link, so the question is, can we call a store procedure via database link? So if you have databases linked together via database links, if you have the REST APIs in database A, and you need to go do something over in database B, your REST call could be select star from something at database 2. And the database goes and gets that thing out of the second database, returns it back to the first database, and then ORDS gets that and translates it. Some people will use ORDS to augment or even start to replace database links, though. So they'll have ORDS configured on multiple databases, and then it allows those apps to then hop between databases via those REST APIs versus going through one database to get to another. Can we write ORDS logic in Python and Polyglot? Not today. But if you want to go Google Graal and Oracle, then at some point that might actually be possible. But right now, all of your ORDS logic is going to be in SQL and PL/SQL. Actually, I think you want to Google Graal VM in Oracle, which is got a preview in 20C. So if you read the tea leaves, if you look into the future, I think at some point, yeah, the answer to your question could be yes, you could do it in Python. And just think about all the kids out there that are doing Python right now. How cool would it be? Well, maybe scary if you're DPA. If you got the high school kids building their REST APIs, and I don't know, I think that's exciting. So yeah, at some point the answer to that's going to be yes. Which means, gosh darn it, I have to go learn Python. I need to learn Python anyway.
Me too.
Yeah, I need to learn Git. I need. By the way, it took for me to do this presentation today. This is like the 6th version of this presentation that I've done over the past 3 or 4 years. I know it's not the best version that this presentation could be, but I've learned HTTP and REST and JSON and all of this kind of ORDS-y type stuff over a long period of time, and I wouldn't expect anyone, even a seasoned web developer, to just get this in a day or two. But when you realize that all you're doing is providing this harness that's able to map the APIs to stuff running in the database, as SQL and PL/SQL, I think that's when the light bulb starts to come on. And then where you have to start getting vigilant is making sure your code has exception handlers built in, so that when something goes wrong, you don't get just that really mean 500 status code back to the user. You know, your PL/SQL is robust. It sees that something went wrong, and an exception handler takes that and sends a nice request, sends a nice response back to the person saying, hey, that's a 403, you made the request wrong. Here's the link to the doc set to go figure out how to make this request correctly. That's when you can really up your game a bit.
So somebody is taking. Thank you for your presentation again, and I don't think we don't have any more questions for the moment.
Someone said the connection was unstable, so I do apologize if I wasn't coming across clearly. There is a version of this video already on YouTube. It's not going to be the same one that I did just now, but it's going to be similar. And if you need links to any of this sort of stuff, you know, just ping me and I'll happily send it to you. And I don't always say this out loud, but if anyone ever wants this content delivered personally to your organization, to your group of developers or DBAs, you know, hit me up. That's one of my jobs as a product manager, is to, you know, talk to customers. And I love talking to customers.
Very nice to know.
Yep. All right, I'm gonna go take a break, and I hope you all enjoy the rest of your evening and the rest of the Groundbreakers EMEA tour.
Yeah.
Ciao.
Thank you so much, Jeff, and thank you so much for the attendees to come here today with us, watching the whole day of the Azerbaijan user group, and also the EOUC part of the Oracle Groundbreakers EMEA too. Thank you so much, and have a nice rest of the day.
Yep.